What happens if the sun just vanishes? No warning, no explosion, just gone, from 1 second to the next. We aren't talking about a supernova. We are talking about instant deletion. The scary part isn't that we die. We all know we'd freeze eventually. The scary part is that for a while, we don't even know it happened. Part 1. The speed limit. So, the sun is gone. But here on Earth, it's a Tuesday. You're stuck in traffic. You're drinking lukewarm coffee. You look up, and the sun is still there. It's warm on your face. The shadows are where they should be. Everything is normal. It's creepy. See, the universe has a hard speed limit. We usually call it the speed of light, but that's kind of a bad name. It's really the speed of causality. It's the maximum speed that cause and effect can travel. Nothing, not information, not radiation, and definitely not gravity, can move faster than about 300,000 kilometers per second. Sounds fast, but space is big, ridiculously big. The Earth is about 150 million kilometers away from where the sun used to be. That means light takes about 8 minutes and 20 seconds to cross that gap. Here's what Newton missed. Gravity travels at that same speed. Newton thought gravity was instant. He thought if the sun vanished, Earth would immediately fly off into the dark in a straight line. But Einstein came along and said, no, mass bends space-time, kind of like a heavy bowling ball sitting on a trampoline. If you yank the bowling ball away, the fabric of the trampoline doesn't snap back instantly. That ripple takes time to move outward. So for 8 minutes and 20 seconds, the Earth is orbiting nothing. We are swinging around a ghost. The gravitational curve is still traveling through space, keeping us in line. The photons emitted right before the disappearance are still streaming toward us. Even neutrinos, those tiny ghost particles created in the sun's core, are still passing through your body by the trillions every second. We are living in a causal disconnect. Fancy way of saying we're clueless. We are literally living in the past. Part 2. The release. Flash forward 8 minutes and 19 seconds. You finish the coffee. Birds are singing. Maybe you are checking your phone. Suddenly the sky changes. It does not fade out like a sunset. It does not dim like a cloud passing over. It is instant. 1 millisecond, it is broad daylight. The next, it is midnight. The sky does not just turn dark blue because it turns the pitch black of deep space. And instantly, the stars are there. Not just the bright ones, but all of them. No sun means no blue sky to get in the way. The stars would not twinkle. They would just burn right next to where the sun used to be. At that exact moment, the gravitational wave hits us. Now, you will not feel this physically. You will not get thrown against the wall like in a disaster movie. Gravity affects every atom in your body and the Earth at the exact same rate. But the planet itself feels it. For 4.5 billion years, Earth has been falling toward the sun, but moving sideways fast enough to miss it. That is all an orbit is, because it is a perpetual freefall. But now there is nothing to fall toward. The bowl of space-time flattens out. The Earth stops curving. We immediately transition from a circle to a straight line. We become a rogue planet shooting off into the void at 30 kilometers per second. The moon comes with us mostly. It orbits us, and not the sun, so it holds on. But the view of the solar system gets weird. Jupiter and Saturn and Mars are still visible. They reflect sunlight, so for roughly an hour, depending on where they are in their orbits, we can still see Jupiter shining in the sky, reflecting the light of a star that does not exist anymore. One by one, they will wink out as the darkness catches up to them. Quick side note, if you are digging this thought experiment, please hit like and subscribe. It seriously helps me create more videos like this. Okay, back to the darkness. Part 3, Day 1. Okay, the lights are out. Gravity lets go. Now the panic starts. First up is total confusion. The internet would light up or crash instantly. People on the day side of Earth would think it is an eclipse, then realize it is the wrong time, and then realize the stars are out. People on the night side would not notice visually at first, until they saw the news that the other half of the world just went dark. You might think we freeze instantly. We do not. The Earth is massive. It holds a lot of heat. Think of a pizza stone you pull out of a 500-degree oven. It stays hot for a long time. The Earth has an atmosphere and oceans that act like a massive thermal battery. Then the heat starts bleeding out. Within 24 hours, global temperatures drop by about 5 to 8 degrees Celsius. That does not sound like much, but imagine the difference between a nice spring afternoon and a freezing winter night happening in the span of a few hours. The moon goes dark about 2 seconds after the sun vanishes. It is just a rock, so no sun means no shine. The only light left comes from the distant stars and our artificial city lights and the auroras. Actually, the auroras would go absolutely crazy for a few days. The solar wind, which is that stream of charged particles from the sun, is still traveling toward us. It takes about 4 days for the tail end of that wind to wash over Earth. Once it is gone, our magnetic bubble, called the magnetosphere, expands outward because there is no solar pressure holding it back. Down on the surface, the grid is in trouble. Solar panels are dead weight immediately. Wind turbines work for a bit. But wind is driven by the sun heating the atmosphere unevenly. No sun means the temperature starts to equalize. The winds die down. The air becomes still. Part 4. The breaking point. By the end of the first week, the global average temperature drops below freezing, or 0 degrees Celsius. This is where the weather turns against us. The atmosphere holds a lot of water vapor, but cold air cannot hold water, which is why you can see your breath in winter. As the temperature crashes, all that moisture in the air has to go somewhere. It starts to rain everywhere, a global deluge. It rains over the oceans and over the deserts and over the cities. As it gets colder, that rain turns to sleet. Then it turns to snow. It is not a winter wonderland. It just does not stop. Meters of snow pile up, covering everything. Plants die first. Without sunlight, photosynthesis stops instantly. Most small plants and tropical vegetation die within days. The microscopic algae in the ocean, which is the stuff that makes most of our oxygen, die off. We do not run out of oxygen, though. The atmosphere is huge, so we have got enough air for thousands of years. But the food chain is broken at the absolute bottom. Supply chains just stop. We have fuel. We have coal piles and oil reserves. But moving them becomes basically impossible. The roads are buried. The rivers freeze. The ocean surface starts to crust over with ice. You cannot drive a truck or sail a ship on a frozen, dark planet. If you are not already near a nuclear power plant or a geothermal vent, you are in serious trouble. Part 5. The surface. Fast forward 1 year. The surface temperature is now minus 100 degrees Celsius. The oceans have completely crusted over. One upside, though, is that ice is a pretty good insulator. It acts like a blanket. So while the top 10 or 20 meters of the ocean are solid ice, the water underneath is still liquid. This is thanks to the Earth's core. The center of our planet is basically a nuclear reactor filled with uranium and thorium. As they decay, they generate heat. That heat seeps up through the mantle and into the deep ocean. So down in the dark, near the hydrothermal vents, life goes on. The tube worms and the crabs and the extremophiles do not care about the sun. They live off chemical energy from the Earth itself. They might not even notice the sun is gone for millions of years. But up here on the surface, it is basically a morgue. The trees that survived the initial freeze are now exploding. It sounds like gunshots ringing out in the dark. The remaining sap inside the trunks freezes and expands, and crack goes the wood as it shatters. The forests of Earth are just fields of splintered driftwood standing in the snow. Part 6. The sky falls. As the temperature keeps dropping, the air itself begins to fail. The atmosphere is mostly gas because it is warm enough to bounce around, but everything has a liquefaction point. If you get it cold enough, air turns into a liquid. First, the carbon dioxide goes. At minus 78 degrees Celsius, it does not turn into a liquid, but instead sublimates directly into a solid. It snows dry ice. This removes the last bit of our greenhouse effect, which makes the freeze happen even faster. Then things get truly alien. When the temperature hits minus 183 degrees Celsius, oxygen turns into a liquid. Take a look out the bunker window. It is raining pale blue liquid. That is liquid oxygen. It pools on the frozen ground. It is highly combustible. If you tried to light a flare, the air would not just feed the fire, because the puddle on the ground would explode. Next goes the nitrogen. Nitrogen makes up 78% of our air. At minus 196 degrees Celsius, it liquefies. The atmosphere literally falls out of the sky. The air pressure drops to almost zero. The Earth is now a vacuum. The sky is perfectly clear and freezes our cities in place. The Earth is now just a rock covered in a layer of nitrogen ice and oxygen slush. One last thing before we talk survival. If you want to help this video spread, hit the hype button below. It helps show this video to way more people, which keeps me super motivated. Thanks. Could humans survive this? Technically, yes, but not on the surface. We would need to go underground. Deep underground. We would need to build massive and airtight habitats. We could not use solar or wind, and fossil fuels would be useless because there is no oxygen outside to burn them with. We would need nuclear fusion or fission or deep geothermal power. Let us say we want to keep 1 million people alive as a seed population. You need to grow food using hydroponics. You need massive banks of UV lights for the crops. You need to recycle every drop of water and every breath of air. The math says you would need about 7.2 gigawatts of continuous power. That is roughly 7 large nuclear reactors running full blast 24/7 just to keep the lights on and the plants growing. But the biggest problem is not making heat. It is getting rid of it. Thermodynamics does not negotiate in a vacuum, which is what the outside world is. Now you cannot use fans or air cooling. There is no air to carry the heat away. You have to radiate it away as infrared light. We would need to build massive radiator fins spanning thousands of square kilometers on the surface. They would glow dull red in the eternal night, trying to dump the waste heat from the city below so everyone inside does not cook to death. It is hell. You are trapped in a metal can eating algae paste, huddled around a nuclear reactor and hurtling through the void. Earth is basically just a rogue spaceship now. We are drifting at 30 kilometers per second toward the constellation Hercules. Eventually, billions of years from now, even the Earth's core will cool down. The volcanoes will stop. The hydrothermal vents will go cold. The tube worms will die. The planet will reach thermal equilibrium with deep space at just a few degrees above absolute zero. We will be a frozen time capsule. The ruins of New York and Tokyo and London will be preserved perfectly in the vacuum, drifting silently through the dark forever. So next time you complain about the summer heat or getting a sunburn, do not. That giant ball of fire is the only thing standing between us and an eternity of frozen nitrogen rain. Thanks for watching.